The Thorium Energy Alliance is basically started in about 2005 as an organization that was trying to talk online in a thorium forum discussion group. And around 2009, we made it official and we became a 501c3 organization. There's a lot of companies like Thorcon and Copenhagen Atomics and others that are developing the uses for thorium as a fuel. So at Thorium Energy Alliance, we've been not only looking at fuel applications for thorium, but we've also been looking at reviving some of the old material uses like alloys, medicines, things like that. We help decision makers and staff in DC understand the issues about molten salt reactors and some of the other options out there for using fuels for these molten salt reactors. They are very flexible, as we know that the molten salt reactor experiment ran on U-235, U-233, and apparently yesterday I heard that the last fuel load was U-239, which is surprising, but somebody can confirm that. One of the things that came out of our discussions with folks in DC and around the country is that in the energy bill last year, we did get this paragraph that you see here that Congress would like a report, fuels besides uranium. And as the example, it was thorium-232 and uranium-233. We actually took them at their word and contacted the DOE once that actually became law and said, hey, we're pretty interested, as interested parties get. How about we give you a little bit of information about this? And so it was a very good opportunity to get to talk with several folks at the DOE, and it's a much delayed report, but I guess they all are. But it should be much more broad-based than the original thought of the report to Congress. So I'm happy for it to take a little while to review, as long as when it comes out, it maintains the optimistic uses for thorium and uranium-233 for not just fuel, but other materials. So we're looking forward to that. If you're wondering what materials there are, you can make superalloys like MagThor, Thorchrome, and AlumaThor. They were used in Gemini spacecraft and all the fighters until the mid-90s. I was surprised at how long they were still making this material. Big in the news lately is cancer treatments from milking thorium. That was a big Oak Ridge project that came into fruition. Superconducting magnets out of Russia, catalysts. Lots of people are looking at the catalytic nature of thorium. Other advanced commercial devices, electronics, magnetrons for advanced microwaves, optics, coatings. Coatings and treatments have gotten very big recently. And the whole reason we pursue this is if we could make thorium a valuable material, then there's a reason to start using it. And we rebuild that history of using it industrially. A little highlight for one name brand company using this stuff is TerraPower. They've been trying to work with Oak Ridge to commercialize the milking process. Bismuth-213 and Actinium-225 have a phenomenal record curing cancers and being a really revolutionary new way to create cancer medicines. Unfortunately, until recently, there's been vanishingly small amounts of it. And so TerraPower is doing good work doing that, but there is a report out there. TerraPower wants to use what they're saying waste. Well, they're referring to the U-233 from the molten salt reactor experiment. There should be more than one player in this area, basically, is our opinion. If there's a reason to save the U-233 and keep it from being downblended, we fully support that. Here's our David Letterman top 10 reasons why thorium should be used as a fuel for molten salt reactors. So we're not just talking about material use, but fuel use. 1, thorium diversifies the fuel supply, and especially for countries like China, India, and Indonesia that have extensive thorium resources and limited uranium. This is the number one reason that I was given by folks in India and China and Indonesia, and there's a lot of activity in those countries regarding thorium. So number 2, thorium provides a great level of political domestic fuel security. There's shipping containers for thorium. There's nothing exotic about it, and it's not new, unlike HALEU, which is still a pretty new critter out there, and there's still some issues in that area. Thorium is separated during rare earth processing. It's a free byproduct from phosphate separation chemistry. Thorium does not need to be enriched in an energy-intensive process like uranium. Thorium is easily handled as a material. It is not nearly as hazardous as some of the other materials that we could be talking about. Thorium narrows the parameter for MSR design and increases safety margins. A national reactor designer for a national project, not in the United States, told me that this was an important feature of thorium to them, that it narrowed what they could do, and so it helped their decision-making and increased the safety margins of their reactor system. Thorium works well with low-enriched uranium, but also what I would call medium-enriched uranium, or HALEU. It works with plutonium. As the Chinese said in their press release years ago, molten salt reactor, not picky eater. So we could use thorium in conjunction with some of these other fuels and even wastes. And in an MSR, thorium can be added to the fuel salt over time to help manage the fuel behavior. One thing that we always like to point out is that thorium has natural proliferation resistance. Thorium itself is not going to be turned into a bomb. So if you have thorium sitting around, no one's going to try and steal it. There's a lot of equivocating where thorium gets converted into uranium, but then it's not thorium, is it? So thorium itself is highly proliferation resistant. I just want to emphasize one thing here, that if we can do this, if we can use thorium as a fuel, if we can use it as a material, we get huge benefits. But if we do nothing more than come up with a modern domestic thorium policy that is logical and reasonable for how we handle thorium and how we store thorium, even if we don't use it the way we should, if all we're doing is storing it, then that alone could revive a domestic rare earth metals industry. And that is huge. If you like renewables, every windmill uses 1,000 pounds of neodymium. All these flat screens that you're looking at need rare earths, all your cell phones, the starter motors in your car. And if we want a high-tech future made with materials domestically in the United States or even somewhere in the West, we need to be better at handling thorium, and we need a better policy for what we do with thorium. The actinide issue is the #1 reason why we don't have a rare earth supply chain in the Western world. Rusty Towel and his team down at the Next Lab at Abilene Christian have put together a stellar network. They're working with Georgia, other Texas universities, other national labs. They've hired a really great crew of people. They've gone deep into the test reactor development and licensing process. I look forward to the day when they make some big announcements. We all should keep our eye on Abilene Christian as a domestic experiment to revive the molten salt reactor project. It should go a great way towards helping our domestic cause in getting this reactor system commercialized. Concurrent with that, there is this company called Clean Core Thorium Energy. They actually are based out here in Chicago. They have developed a thorium HALEU fuel for use in CANDU reactors. I mention it because it is thorium. I also mention it because it is very near term. It's something that could be brought into production very soon. And it is yet one more example of somebody building the supply chain that needs to be put in place. If they get a thorium oxide supply chain started, that could only go to serve molten salt reactor designers. One thing we have to keep in mind, I haven't seen spoken about much during the last couple of days of this wonderful conference, is that we need the DOEs. So the DOE participants in this call, the 278 plus people on this call, we all need to come up with a good policy for developing the molten salt reactor, for developing thorium. Thorium in particular is being utilized by China very successfully. India is utilizing it very successfully. Other countries are very actively looking to develop a thorium fuel supply chain. If the United States can't devote resources to developing a thorium fuel supply chain, then the rest of the world is going to turn the tables on us, and they will tell us how we have to develop our fuel supply, how we have to utilize thorium. And we need to be in the game. We need to work together internationally so that we're all doing things the right way, the most efficient way, economic way for a future of prosperity. We can do it. And I'm optimistic that we can do it. You know, it's not a matter of taking the lead, but we have to have a seat at the table. So hopefully we can all work together to get in the thorium fuel game. So with that, I want to thank you for your time. Thanks for listening to this from the Thorium Energy Alliance. If there's any questions, I still have a minute or two before I get the shepherd hook from Dr. Holcomb.
From James Wishart, for thorium-based MSRs, is a salt fluoride or chloride, or could it be both?
It could be both. Elysium is doing a thorium chloride reactor. I know TerraPower has looked at thorium as an option in their fuel mix. I'm not sure where TerraPower is with that at the moment. And obviously, fluoride is a huge option because that is the original salt mixture with Flibe and Flynac and a few other options that are out there. A guest named Arvind said DOE thorium policy does not support R&D as per recent response. And I just want to, clarify that there have been some policy statements and positions where it is difficult to get funding for thorium-based projects. So that's what I was hinting at, is that if we could be more liberal with our ability to do research into thorium, I think everyone would benefit.
Can a person who's not a nuclear engineer join the Thorium Energy Alliance?
Absolutely. We are agnostic as to how your background is, whether you're a super enthusiast or a very advanced PhD working at a lab. We have everything from excellent researchers, folks like Sid Ball, who helped run the MSRE, all the way down to students that we support who just want to help try and build a thorium fuel future.